So there's a couple features that I've added in here. I've changed this test scroller, the little ant that we played with to start, into something I'm calling a real actor. Now, a real actor, the difference between a real actor and an actor you have is it's using the word real like real numbers, decimal numbers, doubles. This actor can move by partial amounts, whereas the old actor could only respond to integers. So for example, my scroller now, I used to go by 1, but now I'm going to go by 1.5, and it still has to round to the nearest pixel because it can't display partial pixels. But what would happen in this instance, if you move 1.5, the first time it's going to go to 2 pixels. Then when you say move 1.5 again, it's going to go to 3 because it keeps rounding its position from 1.5, 3, 4.5. It keeps rounding those numbers so that it can draw it properly. But it will allow you to move. You would get an error. It would not compile with decimal values if this was otherwise. Now, why would that be useful to you? Things like gravity. You might have specific numbers you want to use. Like on Earth, it's 9.86. You can play with the numbers now with a lot of freedom. You can also create a lot more interesting weapons and things when they don't move exactly by integer coordinates. Because anyways, you have more freedom with where they move if you use decimals. So I've implemented, from what I know of, anyway, everything I believe needs to be done, but it has all the regular methods: turn, turn towards, rotate, set rotation, move, get rotate, all that stuff. You can just treat it as you would any other actor, but knowing that it's storing everything now as doubles instead of as ints. Okay? So let me just compile this so I get my world back. Now what I've got here is a class for you, which is going to demonstrate how platforms work. Okay. Now I'm not going to go through all this code with you. All I'm going to do is show you that this should give me the beginnings of how a platform actor could work. I'm going to let you play with the code on your own time. I've documented it all, so when you want to read up on what things do, it'll all appear for you here in the documentation view and get your specifics that way. Okay. But I'll show you the problem once we get started. As the name implies, it is a platform mover. You must have platforms in your game or it won't know what you're talking about. So anything you want to add needs to be a subclass of this. So I'll show you the difference here. This barrel, for example, it's not a platform. So because it's not a platform, if I put a barrel in the game, the ant is going to be able to teleport straight through it. Okay? However, if I want to change that behavior, so now it cannot, sorry, I have to do a couple things here. I'm going to make this not just a real actor, but a platform mover. Make it a little more specialized, but I'll show you again that it just ignores anything that's not a platform. Okay? I'll change this barrel, and instead of being an actor, I'm going to say it's not just any actor, please treat this like a platform. So it's up to you what you want to make platforms. Now, for example, some of your games have doors. Maybe you want to call that like a portal, a door, a trap door. I mean, there's all kinds of, just because you can bump into it, maybe it's not just a bump. Maybe bumping into it makes you change levels. So you can specialize your platforms as much as you want. You can make different colors, different items. But now when I put it in the game here, the ant will, whoops, just a second here, famous last words. So the problem here is that we've overwritten the act method. That was something I did just to show you the decimals. The idea behind the platform mover was this is how you could use it. The platform mover governs all the rules. You can still change the rules to how it suits you, but I wanted to take as much of the physics out of it as I could. So I've written it this way. I've explained how each of those methods works in the act description. So this is the protocol that happens. So if you want to change the protocol, you have to overwrite it. But because I overwrote it, it wasn't listening to anything a platform mover would do. It wasn't coming in here. Okay? So what I'm going to do is I'm going to put another kind of platform as well. I'll call this ground. Let's go to hopefully it's compile this. I'll put some bricks down here just so that the ant has something to, and then I'll make a big one so you can see it drop. Let's go like that. Okay, so now when I run it, gravity's going to kick in. It's not going to land on Mario though, it's going to land on the bricks. So now when I move, see, he fell between the cracks. That illustrates the first problem. Because right now, this platform mover only checks for obstacles based on its X and Y coordinate, meaning its middle, its center. So the reason it could fall straight between was the middle of the ant was there. Okay? So let me get a bigger obstacle. I think the brick is a fairly large obstacle. And I'll show you here. This time I'll have him work on that. It's a little better. Okay, so he fell, but he didn't fall very far because of the that platform. And I'll put another platform to block where it's moving. So say, for example, I put it there. This ant is trapped now because when it gets to there, it keeps running its head into the platform. I've also put things in. You can take a look at how mine jumps, but I use the space bar for jumping. So for example, if I want to try to avoid falling between there, oops, it's really awkward because of the screen height. Let me, I'm going to make my ant smaller. That'll help. There's a smaller ant. And I'll make the world taller because you can't see them jump right now. So let's make it the full 224. Okay, so here's the ant, and I'll get some bricks. So there's the ant, falls, hits the platform. It's going to die if it falls off there. Okay? This world's unbounded. It falls forever, so you would need to change that behavior if you don't want them to fall forever. But it makes it easy. Now you can ask, Mario fell through the crack. You can ask, its Y coordinate is going to be beyond the screen, so you know it's fallen off your screen. But let's just try the jump here so you can see. Mine is the space bar that I've connected. I don't know if the ant can handle that big, but we'll find out. Couldn't go that far. You'd have to change the speeds that it moves at. But I'll put the bricks a little closer. It's kind of cheating, I guess, but I've told you how bad I am at video games. Okay, one more time. You might have noticed there too that the ant fell through the brick because again it's only based on the center. So let's, hey, I'm alive. Okay, so again it's just the basic constructs of the jumper, the keys and the space bar. But what you're going to want to take a look at when you do this is how it decides whether something is near it, and this is what you have to go and fix. So the methods that I have, the protocol is this. You make the actor move, you apply a little bit of gravity, and then you check to see if it collided with something. If it did, you move it back so that the visual of the person seeing it will never see it happen. It's basically like if Mario is the cursor and it moves left, it bumps into this yellow block, so I bump him back to here. So the net result is the person would have seen this movement. They wouldn't have seen Mario enter the block and back up. So that's what this check for collisions does. It backs things up so that it looks like you're hitting an obstacle. And there's 4 things you need to check: up, right, down, up, left, right, and down. So when I say check for ground, there's this method called get an obstacle below. And this is what you're going to have to rewrite, because the only thing I do right now is I use the middle of the actor, and I say if somebody's right in the middle, so you could imagine it if something is basically right at your, I guess, your stomach, then it registers it as an obstacle. But I'll show you another weird error that would happen. Let's make the image bigger again, and I'll put a brick over a brick. So here's a brick. And I'm going to put this brick slightly higher. So you think that it would trip the ant if it was here. But it just moves straight across it. You notice it's not moving itself up until much later. It goes straight through and then up later. That's because it didn't hit, the center of the ant is right there. So it's only checking that one point. And if I back him up to where he started, that point right there, it doesn't hit a brick anywhere. So what you're going to do is make a loop that will start at the top of this player and end at the bottom so that it knows to check multiple points down that spot. Now, it's overkill to check every single pixel. Your game will be laggy. So you only need to check several. Maybe you want to check top, middle, bottom. That means you need a loop with 3 points. Maybe you want to check 10 points on each side. So you will basically write the loop, which starts at the corner to corner, and your loop will define how many points it goes through. So I don't want it hard-coded. I want you to write it so that the loop will check multiple points for you. So your job is to improve this set of methods. Obstacle below. There's another one. Get obstacle above. Get obstacle on the right. And then, of course, there's left as well. Okay? So you will rewrite those to do a better checking of obstacles than I did. That's the other loop you need to do to finish that off and avoid that weird behavior where it started. But it should provide the constructs you need to get your basic platforms here. I don't know what jumping is going to look like for this. That's not bad. Okay. Anyways, but it'll give you your basic constructs, and we will talk about building your levels in Double Block.